So in this video we're going to use completing the square to find the standard equation of a sphere. So the directions are complete the square to find the standard equation of this sphere. So we'll start by rewriting what we have. So this will take a minute and be boring. I could give you a poem or something, but I won't. And then I'm going to need some space. I'm going to put my equals 0 way over here because I'm going to wind up needing quite a bit of space. And so the first thing to remember when we complete the square is we need to group variable terms together. So the x's need to go with x's, y's go with y's, z goes with z's. So I'm going to take the 9x squared here and I'm going to group it with the minus 6x plus the 9y squared. It's going to get grouped with the plus 18y, and the 9z squared is going to get grouped with the plus 9z. And then I'm going to subtract this 1 from both sides to get the constant term out of my hair. So I'm going to put the minus 1 over there. And then the next step in the completing the square process is to remember that the leading coefficient on the squared terms has to be 1 when you complete the square. That's a key part of the completing the square development when you're in pre-calculus. So I'm going to take this 9 and I'm going to factor it off of the x terms. So that's going to give me an x squared minus 6/9 x. 9 times 6/9 is 6, and then 6/9 reduces to 2/3. So I get 2/3 x, and I'm going to leave some space for the completing the square process. Plus, I'm going to factor the 9 off of the y term, so I get 9 times y squared plus 2y, and then I'm going to leave some space for the completing the square process. And then the same thing here, we factor 9 off the z squared. And again, this is because the leading coefficient on the squared terms need to be 1s. So 9, we'll get z squared plus z, and leave some space, and this equals -1 over here. And then remember that completing the square process, you take the coefficient on the linear term. So the coefficient on the linear term here is a -2/3. And you take half that coefficient on the linear term and then you square it. So here I'm going to get a -1/3, and that's going to get squared to give me a 9th. And then you come in and you add that 1/9 to the x stuff. And then you have to identify how much did I really add. So by the distributive property, this 9 needs to distribute in here. So by adding a 9th, I've actually added 9 times 1/9 is 1. This is the same as adding 1. So if I add 1 to the left-hand side, I need to step over and add 1 to the right-hand side as well. And then I step over in here, I find the linear term. There's y, which is the linear or first power term. I take half of its coefficient on the linear term. Half of 2 is 1. I square it. 1 squared is 1. And I add that squared quantity to the y terms. And then I say, how much did I really add? Well, I really added 9 times 1 is 9 to the left side. So I step over here and I add 9 to the right-hand side as well. Here, the middle coefficient is 1. So half of 1 is a half. We need to square a half to get a quarter. We add a quarter to the z terms, but we really added 9 times a quarter is 9/4 to the left-hand side, so we're going to add 9/4 to the right-hand side as well. And then the next step in the completing the square process is to recognize that you just completed a square, so you need to write the square that you completed, so it's going to be x. And then what goes next is the thing that you squared. So in the case here, where the middle coefficient was -2/3, I took half of -2/3 was -1/3, and I squared a -1/3. So because this is what got squared, that's what goes here. And if you were to square this out as a check on work, you should get this second degree polynomial inside the parentheses back. -1/3 times -1/3 is 1/9. -1/3 times x twice is -2/3, and x times x is x squared. And I have my 9 sitting on it. Plus 9 times I completed the square in here. What square did I complete? Well, it's going to be y plus 1 because I took half of 2 is 1 and I squared a 1 and added it. So that, again, the thing that gets squared is what happens right here, and you need to keep track of whether it was a plus or minus that got squared. And then finally over here I'm going to have z, and then what did I square? Well, I squared a half, so it's going to be plus a half squared equals, and now I need to simplify this, so negative 1 plus 1 is 0. 9 plus 9/4 is going to be 36 plus 9 over 4, which is going to be 45 over 4 when we get that common denominator for the 9. And then we're almost done. We're going to multiply right now both sides by 1/9 to get it into standard form. So 9 is going to go into 45 5 times, leaving us with a 5/4 right here. And then we're going to have our squared stuff. So it's x minus a third quantity squared from right here, because multiplying both sides by 1/9 will kill all of those 9s. And then we get y plus 1, and then we get z plus 1/2. And there's the standard equation of the sphere. And then we could take this one step further if we wanted to write it so that it had the minus format. So y minus negative 1 quantity squared plus z minus negative 1/2 quantity squared equals 5/4, because if we write it with minuses, sorry, right here, if we write it with minuses, then we can read off the coordinates of the center of the sphere very easily. So this final result, two things we realized: that the radius squared, because the equation of a sphere, when we look at the standard equation, the number that you get over here, that constant term, is the square of the radius. So that tells us that the radius squared is 5/4. So if we needed to know the radius would be the square root of this, which would be root 5 over 2. And the center of the sphere would be the coordinates x naught, y naught, z naught equal to 1/2, negative 1, and negative 1/2.